Oops. There we go. All right. Welcome back, wonderful people. Let's get started. So what we got going on today, so we're going to graph absolute value equations by finding the vertex and determine the domain and range. And if we have time today, we'll go ahead and also graph absolute value inequalities in the same manner by finding the vertex and determining the domain and range. All right, so let's see what we need to know about absolute value functions. So the absolute value function is written like this. It's got this f of x, which again can also be used in place of y. And we have these brackets that are kind of straight up and down. So they're a little bit longer, a little bit taller than a regular bracket, and they don't have any of the top parts. They're just kind of these vertical lines. And remember that the absolute value operator means that whatever you put in there is going to become positive because it represents a number's distance from 0, and distance cannot be negative. So let's see what we have here. So complete the table below and graph the function, and then give the domain and range. All right, so they give a basic function, which is this thing here, sometimes called the parent function, which is the most basic form of that type of function. So what this is going to be like is it's going to be like, so if I have f of -3, that means that I put -3 in here. So, well, if it's a -3, it's going to turn it into a +3. So f of -3 equals +3. So I'm going to put +3 right here. And then I'm going to do the same thing with f of 2. So f of -2 is equal to the absolute value of -2. And if I take the absolute value of -2, well, again, that's going to also turn it positive. So we have +2. And then same thing with 1. You can already tell if I grab -1 and I put it into the absolute value, that's going to turn it into a +1. 0 will become 0. Well, it stays 0, I should say, because there's no such thing as a negative or positive 0. And then you also have 1, which is positive, and remember, this is not a sign switching. It makes it positive. So distance cannot be negative, right? If you get in your car and you drive backwards, you didn't go -10 feet. You went 10 feet in another direction. And the same thing with 2, if I were to put 2 in here, f of 2 would be +2 and 3 would be 3. All right, so now that we have our ordered pairs, let's go ahead and graph them. So -3 up 3 is our first one. -2 up 2. -1 up 1. 0, 0. 1, 1, so over 1 up 1. Over 2 up 2, and over 3 up 3. And this is going to be a straight line. It's going to be a line graph, a line function, because, well, if I were to pick any other number, like let's say instead of -1, I picked -1.25 or -1.5, they would still be viable solutions. It would still work out. I would still get an input. I would still get an output. So this includes all numbers between the numbers. Remember, so this is a continuous graph, not a discrete graph. Discrete graphs can only be certain numbers, like numbers on a dice. Continuous can be anything in between. All right, so now we have our domain and range. So domain is going to be all real numbers. And I'm going to just put all reals because it fits a little bit better. The range, however, and again, this is the one that's a little bit tricky. Ranges are a little bit tricky because they generally don't have to follow any sort of special rules. So to determine the range, you're going to take a vertical line, or sorry, a horizontal line, and you're going to just sort of start from the bottom and work your way upwards. I have nothing, there's no part of the function until I get to about 0. But I have to ask myself, can I actually pick 0 itself? And the answer is yes, I can pick 0 itself. So what does that mean? Oops. So if you can pick 0 itself, that means that you would have an or equal to statement. So y has to be greater than 0. And we have the or equal to there. So any y above 0 can be part of our range. We can pick that. So again, just like the last one, sometimes the range can be a little bit tricky because there are less rules governing the range. Y values can just sort of do whatever they want. So looking at the graph, it kind of looks like, if I ask you to describe it, you would probably say a V. It kind of comes down, stops, and then goes back up. And where it changes direction, we call that the vertex, or here they call it the turning point. So that's where it kind of turns and goes into a different direction. So that's hopefully most of what you need to know about absolute value functions. All right, so graphing them. So to graph them, well, there's a couple of different ways to graph them, but this is probably one of the most reliable ways in terms of like ease of, it's really easy to remember it. Okay, I was about to say ease of remembering, but that doesn't really make a whole lot of sense. But it is easy to remember, and it works with just about any kind of function. Even if, like, say in the future, you know, if you're ever taking a college entrance exam and you're like, oh man, I don't remember how to graph parabolas or something like that, it would be a lot easier to think, okay, well, I can always use a table no matter what. I can always use a table, and if I make a table, then I can find at least where the turning points are and, you know, zeros or any kind of key features of the graph, and then go from there. All right, so to create a table of values, it's best to place the vertex in the middle and then include some of the numbers on both sides. So first thing we got to do is find the x value of the vertex. Set the expression from inside the absolute value bars equal to 0 and solve. So set it equal to 0 and solve. Place this value in the middle row of your table and then graph it. So basically kind of what we did with the introduction here. So again, vertex is in the middle, but this is not the parent function. The parent function is usually very simple, but anytime you change it, it is gonna make it more complicated. So let's go ahead and look at this one here. So I have f of x is equal to the absolute value of x minus 4. So what we're gonna do is we're going to take the expression inside the absolute value and set it equal to 0. So it's just gone, right? We just want to know where the middle is for now. And I'm going to add 4 to both sides, plus 4 here and plus 4 there. So x equals, well, in this case, it looks like we get 4. So this means that we should put 4 in the middle row. So there's about 7 boxes, and the middle one would be, well, 4, the fourth one. Now that way we have a middle. Now I'm going to just pick some values counting downward. So 4, 3, 2, 1, and 4, 5, 6, 7. And that should be most of what we would need. Now we also have to take these, plug them in, and then take the absolute value of each one. So for this first one here, I have f of 1. And if I were to plug that in, I'd get 1 minus 4. So 1 minus 4 would be -3. Now we only have one number in there, so I'm going to take the absolute value of -3, which would be +3. And there we go. So we have one of our ordered pairs, but let's get all of these done before graphing them. The next one would be 2. So f of 2. So this would be 2 minus 4, which would be negative 2, but we take the absolute value of that and we get positive 2. All right, now we can also get, we'll have to do the same thing for 3. So plug 3 in there. So 3. Do that a little bit better. Let's see what we get. So f of 3, so 3 minus 4 would be negative 1. And take the absolute value, so we'd have positive 1. And then last one we need to work on will be 4. And we should expect our vertex to be the number that we found. So the vertex, again, that's where the graph is going to turn around, turn into a different direction, I should say. So 4 minus 4 would be 0, which the absolute value of 0 would stay 0. We don't have any change in it. And then we do the rest of them just the same. So plug in 5. So f of 5 is 5 minus 4, which is positive 1. But we also take the absolute value of positive 1, which would just be 1. All right, we don't change the sign, and usually it's going to stay positive, but that doesn't always mean we're going to have a positive result. Sometimes you can have something like this, where a negative is on the outside, which in that case you will get a negative result. But that's just a heads up for now. Let's go ahead and keep doing this until we get all of them. So 6 minus 4. And 6 minus 4 would be 2, but absolute value of 2 stays 2. And last one is, oh, I wrote 5. Well, I still got the right answer. I just noticed that I didn't put the right number here. Or maybe I don't know, maybe I didn't erase it from the last time. 7 minus 4 would be positive 3, but if we take the absolute value, we still get 3. Now from here, we can go ahead and start graphing it. So over 1 up 3, and then second point is over 2 up 2, over 3 up 1, over 4, 0. And again, this middle area should be our vertex. So over 5 up 1, over 6 up 2, over 7 up 3, which it does look like that middle was our vertex. And you're also going to have, now this is not part of the lesson, but you're going to have this axis of symmetry is what we would call it, meaning that it's kind of like a point where it's going to be the same on both sides, which if we look at these lines, they are going to be kind of facing the same direction. Oops. Right, they're both going to be like 1 space away, 2 spaces away from the middle, 3 spaces away from the middle, and so on. And then from here, we would just connect our dots. So let's go ahead and connect here. And then make sure, as always, anytime you're graphing, you want to go from one side all the way to the other side. Because graphs, graphs don't look like this, okay? They don't. That is not an accurate representation of a graph because graphs go on forever, and that's why we have these little arrowheads to show that that's what's going on. That line is going on forever. Because you could put any number in for X. You could put in 100,000. You could put in 2 million or anything like that. So anyway, last thing we have to do with this is to determine the domain and range. So after we graph it, give the domain and range. And again, follow the directions. So in this case here, our domain has no holes or gaps in it. And again, domain is usually kind of the easier one to do. So all reals would be what we would have here. And the range, well, in this case, it's kind of the same thing. We kind of have to imagine a line, a horizontal line coming up and looking for the lowest value, which in this case is 0. And we want y values greater than, oh, that's not greater than, that's less than. So we want y values greater than 0. But we also include 0. So if I'm able to get 0, see, I'm able to get 0. If I wanted a y value of -1, I can't do that. There is no number that I can plug in for x so that I get -1. And we've already seen kind of one of them. We saw what would happen if we were to plug in 3. Right, if we plug in 3 minus 4, we get -1, but we still have to take the absolute value of it. So we don't actually get -1, so -1 is not a possibility. We can get 0 though, which we did. We can see that in our vertex. So since we can get 0, we are going to put the or equal to line underneath. And there we go. So that's one down. And there's kind of an easier way to do this too, but like I said, it's kind of special for well, I guess it's not really, well, maybe I'll kind of go over it, and if you want to try it out on your own, you can, but let's focus on one thing at a time, okay? So let's go ahead and do this one here. So I'm going to plug in 0 for f of x. So in this case, it'd be 2x plus 6 equals 0. And I just use reflexive property, so I move 0 over to this side, and it means the same thing. I just like having the variable on the left side. It just makes it a little bit easier. So I'm going to minus 6 from both sides, and that's going to give me 2x equals -6. Divide both sides by 2, so I'm just doing basic solving. Divide both sides by 2, and I managed to get y equals -3. So this tells me that -3, if I were to draw a line, I would have it would match. It would look something like this, or I don't know where exactly it is just yet. Well, actually, there is kind of a way to tell, but we know that there's going to be the vertex is going to be somewhere on -6. So let's go ahead and make that our middle value. Oh wait, no, sorry. What am I talking about? -6 divided by 2. And let's see, the 2 was so far down, I was like, I almost didn't see it. So and in fact, it'd be -3. In fact, I wrote -3, so I knew I was thinking of -3 because I marked the line there. But I don't know why I put -6 there. Anyway, let's go ahead and put some numbers, and hold on a minute. That's not the way down. If you're talking about numbers that go lower from -3, right? So there's -3. We want numbers that are going low. The next lowest number would be -4. And that would be -5 and -6. So be careful when you're working with negatives. I guess it really wouldn't make a difference if you were to go backwards. Yeah, it probably wouldn't make any difference whichever way you go. You know, you could have put the -6 down here and the 0 up here. There's not really like a way to get this really wrong or anything. Okay, so we're gonna have to plug each of these in. So f of x. Okay, hold on. I'm going to move it over a little bit better so that it kind of shows up a little bit better. So f of x, but we want f of -6. And that's going to be 2 times -6 plus 6. An absolute value of the whole thing. So 2 times -6 would be -12 plus 6. And then -12 plus 6 would be, well, -6. But we take the absolute value of that, and we would get 6. And maybe I should have given myself some more space to write this out. But we're going to do the same thing with all of our other numbers, too. So I'm going to just use the same thing here. Same way I did kind of the last one. So I'm going to put in -5 now. So 2 times -5. All right, so 2 times -5 would be -10. And then I have to add 6 to that. So that'd be like 6 minus 10. 6 minus 10 would be -4. So that would mean that we'd have the absolute value of -4. But again, it's going to turn it into a positive. And then moving on, and I know that the paper that you have is kind of, it's about the same size. So you might not have a lot of space to work all of these out. So in that case, you probably would need to use a separate piece of paper. So let's go ahead and put 2 times -4 in here. 6 minus 8 is -2. But again, absolute value of -2 is +2. Do the same thing here, put 3 in. 2 times -3 is -6. -6 plus 6 would be 0, which again, 0, there's no absolute value of 0. It's just going to stay 0. And from here, we should expect the pattern to repeat itself. So if we chose the correct middle number, it should go back the same way. So it should be 0, 2, 4, 6 down here. So 0, 2, 4, 6. Because again, it should be symmetrical, meaning it should be the same on both sides. So let's go ahead and put -2 here. 2 times -2 would be -4. And 6 minus 4 is 2. So that, again, it works out that way. It should. The next number should be 4. So let's go ahead and plug in -1. So I'm going to go ahead and plug in -1 right here. 2 times -1. Well, that'd be -2. 6 minus 2 is 4, and absolute value of 4 is going to stay 4. And then 0, well, okay, so that one should be kind of easy. 2 times 0 is 0 plus 6. Well, 0 plus 6 is going to stay 6. And absolute value of 6 is going to also be 6. Now we should have enough to graph our entire line. So go back 6, up 6. Back 5, up 4. Oops, that's not 4. Up 4. What's the next one? -4, up 2. And then -3, 0. Okay, so we already have that part marked out. -2, up 2. -1, up 4. And then 0, 6. Now, I did say there's kind of a shortcut on this, but be careful, because just like any shortcut that you kind of use in real life, okay, if the shortcut was the best way, then it would just be the way. There wouldn't be a shortcut in the long way. So usually whenever there's a shortcut, there's usually a little bit of danger in taking it. So if you're not sure, just stick with the best way, okay? So what the shortcut is look at this line and imagine it like a linear function. Y equals mx plus b. Starts at b, up 2 over 1, up 2 over 1, up 2 over 1. So you can kind of see that there is a pattern, but you still also need to know where this line will change direction, where the vertex is. So again, that's kind of a hint. Hopefully you're thinking and you're like, oh wait, I can kind of see it now. But you can also use that to check your work. So still do the table, okay? It gives you a table, so you should use it. So, oh, we didn't even finish drawing the graph. So let's go ahead and do that right now. So I'm gonna go ahead and graph it here. Make sure that our function has nice lines that go all the way to the edges of the graph. So there we go. Now this V is a little bit narrower. Sometimes we call this a stretch because it's like grabbing the line and pulling it, you know, up and down ways. Oops. So now that we see our line, let's go ahead and get our domain, which again, domains are usually pretty simple to understand. The range in this case is pretty much the exact one as the other one, right? So if we look at both of these graphs, they kind of start in the same direction. They both start from 0, and they also include 0. So we should put we can get any y value as long as it's greater or equal to 0, which again, we have 0. If I want 0, I just plug in -3 and I'll get a 0. Right, but there's no number I can plug in here to get -1. It's just not gonna happen. Okay, so how am I doing on time? And I'm not sure how I'm going to do this one. I might have to break it into 2 lessons again, but I don't want to slow down the lesson pacing too much. So if I don't get to it, maybe I'll just assign it as extra credit. Okay, so let's look at this one here. This one is a little bit different because this is not inside of the, it's not inside of the absolute value expression. So we should take the absolute value of x and then add 5. Okay, so the first thing we need to do is find out where the middle is. Where is the middle in this case? So we should, now here's where it's a little bit different because it says, if we look at the directions, where are they? Oh, nope. Let's see. Set the expression from inside the absolute value bars to 0. So in this case, we don't include 0. I'm sorry, we don't include 5. So 0 equals x. And that's it. So I know that 0 is the middle number. So again, we ignore the 5. When we're looking for the vertex, any numbers on the outside don't count because again, the directions say anything inside the absolute value should be set to 0. Anyway, let's go ahead and put some values in there. So fill that in. Okay, now it looks like we're ready to work some of these out. So let's see, I can put in -3 plus 5 like that. So that would be my first one here. And I'm going to take the absolute value of 3, and that would just be +3 plus 5. So that tells me my first value is going to be 8. All right, so we got 8, and now we should do the next one. So this is going to be -2. Oops, let me erase that a little bit better. So -2. But if I take the absolute value of it, I'm just going to get +2, and 2 plus 5 is 7. So I already know what the next one's going to be. Now time for -1. So let's put in -1 here. -1, if I take the absolute value of that, it's going to be +1. So 1 plus 5 would be 6. And next one would be 0. And again, this is where we should expect the line to change. So 0 plus 5 would be 0. Because again, it's already an absolute value. And then plug in 1. And if you're working on this, you don't need to erase it. I'm just doing it just because I don't have a whole lot of space to write these on. And if I take the absolute value of 1, it's just going to stay 1. And I just get 1 plus 5, which is 6. 2 plus 5 is 7, and 3 plus 5 is 8. But again, this line, this column here, should be the same on both of them. If you pick the same, one number apart, it should be the same, which all of these are one number apart on the x side. Since they're all only one number apart, these numbers should match. So now we should be able to graph it. So -3 up 8, -2 up 7, -1 up 6, okay, yeah, that's right. And then 0, 5, over 1 up 6, over 2 up 7, and 3, 8. There we go. So my absolute value function, the v thingy, is way high, right? It's way up here. So let's go ahead and connect them. And from here we can use this, and again, domain, it goes on forever, sideways in both directions. So there are no holes or gaps or anything like that. So domain should be fairly easy to okay, I just got a message that the elementary school got shut down. They didn't say any reason why, but I just looked at the message and it looked important. So I decided to go ahead and check that, which I normally don't do that. But you never know, it might say something like, we're evacuating the building or something, and they don't want to, well, I guess if it was that bad, they'd probably just announce it. All right, so now in this case here, the range, our minimum value is way up here. So we want Y values, we want Y values that are greater than, let's see what's the, well, I can look right here. The lowest number we can get is 5, and we can pick 5 itself. So our range in this case is going to be Y equals 5. That was kind of easy. Okay, how am I doing on time? Actually, this is a pretty good timed class, I guess. I hope I'm not moving too fast. Okay, so let's go ahead and do this next one here. So first off, again, only what's inside of the absolute value should be set to 0. All right, and let's see, I'm going to minus 2 from both sides. So 3x equals negative 2. Ooh, no, this one looks like we might have kind of a weird thing going on. Because in this case, it says x is equal to negative 2/3. So what should we do? Well, let's still try to get negative 2/3 into our box. And I'm going to kind of make it the slanty fraction instead, just because I'd have the numbers really squished or compressed if I was going to put them in there. All right, so negative 2/3 would be about right here, a little bit further away than half into the negatives. So I still want numbers that are going to be going down and some numbers that are going to be going up. So let's go up first. So the first one would be 0. So 0, 1, 2. And then I want numbers that are going down. So going down, right? I want, let's see, negative 1. We still want to pick whole numbers. We don't want to pick fraction numbers if we can avoid it, because, well, we want it to be verifiable. We want to be able to check to see if it's true or not by seeing if it is the same on both sides. So again, we got to pick whole numbers and one number apart after the fraction. Okay, so let's go ahead and start plugging in numbers. So I'm going to start with, well, I'll start with negative 3. So 3 times negative 3 plus 2, and then absolute value. And in this case here, negative 3 times 3 would be negative 9 plus 2. And let's see, this would be absolute value of negative 7. So it looks like I'm going to get the absolute value of 7. Well, actually, it'd be positive 7, but I meant to say absolute value of a negative would be positive 7. But again, just remember, anything you put in there is going to become positive. And then same thing with the next number. So I'm going to go ahead and put in negative 2. So just, and again, this is just for me to easily, write the same thing because I don't have a whole lot of space. So in here, I'd have negative 2 plus, like negative 6 plus 2. Although I would normally think of this as 6. Never mind. Okay. I'm getting Okay, so there you go, 7 and 4. And then let's go ahead and plug in the next one. So this would be -1. So 3 times -1 would be -3. 3 times -1, well, -3 plus 2, -3 plus 2 would be -1. So that would mean we'd get +1 here. All right, now we have the fraction. So hopefully this is, well, I can, okay, let's not ruin it. Let's see what we can get. So -2/3. So remember, when you're multiplying times a fraction, you want to multiply the whole number to the top number, or you can put a 1 underneath this number here and then multiply the tops and then the bottoms. But the bottom's usually not going to change because 3 times 1 is always just going to stay 3. So in this case, it's going to be 3 times -2, which is -6. -6 over 3. So that's -6 divided by 3, which would be -2. -2 plus 2 would be 0. And like I said, I could kind of see where this was going, but sometimes we just got to make sure. All right, so that was probably the only difficult one. The positive numbers actually are a little bit easier as well. So you've probably already noticed that if I plug in 0, I get, I get 3 times 0, which is 0. 0 plus 2 is 2. And this one's a bit of a weird one. Well, let's see if it still is symmetrical. Let's see if our line still works out. Let's go with 3 times 1, which is 3. 3 plus 2 is 5. So maybe you can't always use the vertical test to see if anything, the mirror test or the reflection test to see if something's working out. And it's probably not working out exactly because this is not exactly in the middle, right? It's between these two numbers. But you know what? Maybe this will still work out. Let's go with 3 times 2, which is 6, and that'd be 8. So absolute value of 8 is, well, 8. All right, so -3, 7. -2, 4. -1, up 1. Oh wait, no, I missed that last point here. This should be up 1 more. And again, it should be a straight line. So if it was a bit lower, you notice that it wouldn't make a straight line from here to there. So sometimes, you just got to look really closely on some of these. All right, but let's keep going. So we already know that our vertex is marked here. So 0, 2, over 1, up 5, and then over 2, up 8. So again, this line doesn't match perfectly, but if we draw our graphing lines, it actually doesn't look that bad. It still looks very symmetrical. It looks like it is going to pass the symmetricality test or the test of symmetry. So I guess this is a good example of, sometimes it doesn't work, but if it has a vertex on a full number, on a whole number, then it is going to be, your table is going to be symmetrical as well. In this case here, maybe if we picked other numbers like maybe, maybe if we see this again, we'll try that. Okay, we'll try something different. I don't see anything with going on weird with the domain, and that doesn't mean that it never happens. Okay. But again, domain is usually a little bit more stable in how its rules are used. So the range on this case now, I did go a little bit lower. That's just my marking of the vertex. Oops. So yeah. But the actual low number would be 0. So we want y values greater than 0. in our range. Okay, so it's been about 40 minutes. I'm gonna see how far I can go into the other one. I think we can go ahead and maybe almost finish the entire lesson today. So I've been, like I was saying earlier, I think I was worried about going a little too fast, but I think I can finish the entire thing today. I was kind of worried because I didn't want to split it into two of them, because if I split it into two lessons, then we would have something to do on Friday. Oops. Anyway, so let's go ahead and do this one here. So this one's a little bit of a different one because you notice that there's a negative on the outside. And remember, I warned you about this before. I warned you that it's not always going to be a positive result. In fact, where did I put that example? Oh, right up here. So it's not always going to give you a positive result because sometimes you have a negative on the outside. So how does this affect our graph? What is it going to do? All right, so again, only the part in the absolute value expression will be set to 0. So in this case here, I have x plus 1. Just going to minus 1 from both sides. X equals -1. So I know that -1 is going to be my middle number. And again, right here is where -1 would be. So if I want to go up, I'd have to go 0, 1, 2. And then I want 3 numbers down. So that's going to be -2, -3, and -4. Okay, so now that we have our numbers, let's start plugging things in. So negative absolute value of -4 plus 1. I'm going to make these a little bit more visible. All right, in this case here, I have -4 plus 1, which would be -3. Now, if I take the absolute value of -3, I'm going to get +3. Okay, now, just like with some of the other grouping symbols that we've covered, like brackets, braces, and the other one we covered, the greatest integer function, you treat those just like parentheses. So if I evaluate this negative so that it would be, I use it so now that the absolute value turns it positive, that negative is still there. So this is like negative times 3, which is going to give me -3. It's going to turn it negative. So it's kind of like a washing machine, right? If you, let's say you're washing clothes and you want to put it onto a clothesline. As you're taking some of them out in the basket, right, and you take it outside to put it on the clothesline, some of the clothes will fall off into the dirt, and that's going to cause it to get dirty again. So even though it got washed, it just ended up with the negative again. So yeah, it's going to stay negative. All right, but let's go ahead and keep going. So in his case here, I'm going to go with -3. So -3 plus 1. So -3 plus 1 would be -2. Use the absolute value for -2 so that it's going to become +2, but you still have this negative. That one's not affected, right? So it's not affected. It's going to jump right onto this and make it negative. And now it looks like we're going to have to do another one, negative. So that's going to be -2. -2 plus 1 is going to be -1. Take the absolute value of -1, that's going to become +1, but the negative is going to jump on it once it's out of that parenthesis. And then let's see what we got here, -1. So -1 plus 1, well, that would be 0. -0, well, okay, there's no such thing as -0. So even though there's a negative here, we evaluated it. You know, the negative just doesn't stick to 0. Okay, it just can't stick on there, like a non-stick pan. That's a bad analogy because I don't think I've ever run into a non-stick pan. Or I should say a truly non-stick pan. Something's always going to stick to it. All right, so let's see, 0 plus 1, we have positive 1, which I don't need to change the sign because it's already positive. And then here I got, well, it looks like it's going to become negative 1 again because that negative is going to jump on that 1. And then here I got, wait, did I skip 0? No, wait, oh. Okay, this is 1 plus 1, that'd be 2, and that would give us negative 2. Okay, for a second there, I thought for some reason, like 0 or negative 1, 0, and 1 and 2 kind of really have very similar, they look very similar, and they actually do have some similar outcomes to this, but okay. Ooh, I got a little confused there. Okay, so 2 plus 1 would be 3. Take the absolute value of 3, which is already positive, so that's going to make it negative 3. All right, now we should have all of the data points we need to fill this graph out. So it's going to be negative 4 down 3, negative 3 down 2, negative 2, negative 1, and then let's see, 0 would be negative 1, 1, negative 2, over 1 down 2, over 2 down 3. Whew. Okay. It looks kind of the same, doesn't it? I mean, it looks sort of like it looks like a regular it looks like a regular V absolute value function, but it's opening downwards. Maybe if I have some time, I'll kind of go over showing you that. But anyway, let's go ahead and get this one finished up. So again, unless you see anything really out of the ordinary, I'm pretty sure all of these are just going to be all reals. And again, the range, we got to do a little bit of thinking about it. And in this case here, we want Y values that are less than 0, right? Because I can't pick anything greater than 0. Like if I pick positive 1, that would be greater than 0, but I can't pick it. I've already, tried these numbers that would give me a value over 1, but it just doesn't. It's just not working out the same way it should. And again, we can pick 0, so we can get this y, the f of x. Remember, that means the same thing as y. It can equal 0. All right, now this kind of tells me it's going to be a little bit, after this, it's going to be a little bit more difficult because now we're getting fractions in here. So let's go ahead and find out what the vertex is, where the vertex is going to be. So for this one here, I'm going to go ahead and let's see, 1/2 x plus 1 and equal it to 0. So I'm going to minus 1 from both sides. So that way 1 stops being on this side and it moves over here. And let's see, how was it we get rid of these fractions? I mean, you would say, well, can't we just divide both sides by half? Which is normally what we would do. But remember, if you multiply something by a number's reciprocal, so like 2 is 1 over 2, that means you're dividing. So that means we're going to have to times both sides. Oops. So that means that this vertex is going to be at x equals -2. Whew. So that means it's going to be somewhere on this line. And it's probably going to open upwards because there's no negative here. So, and that's actually really important because a lot of other functions like parabolas if you make the x negative or do something to make it negative, it's gonna make it open in the opposite direction. Or actually, I should say, well, specifically for order of absolute values, it would have to be on the outside, which in this case it's not. So let's go ahead and put in -2 in our middle. -1, 0, 1. And then as I go, I have to go back this way. And let's try to, oh gosh. Let's try to get this one. So 1/2 times -5 plus 1, and then absolute value that, then subtract 4. All right, so if you need a calculator, go ahead and do that. But like I said, multiplying a number's reciprocal, so like if you take 2's reciprocal, instead of 2 over 1, you get 1 over 2. So you flip the fraction. That turns it into a division. So this is -5 divided by 2. So that would be -2.5. And this one might be a pretty good one to translate into a decimal, which I'm usually against, but if it helps in this case, then go ahead, because you can get an actual true decimal value, not like 2/3, because we had one in an example. We can't change that into a decimal, because then you'd get like 0.66666, and you can't really calculate repeating decimals. All right, so let's see what we got here. So -2.5 plus 1 would be -1.5 minus 4. And that would be 1.5. So this is 1.5 minus 4. And in this case here, where did my calculator go? You can use a calculator if you want to on this one. This one is one of those. 1.5 minus 4. And we would get -2.5. Okay, so luckily I think it'll be a little bit easier when you're working with even numbers, because if you divide an even number in half, like if I put -4 in here, well, half of -4 is -2, and that's going to give me a whole number and not a decimal number. So 1 minus 2 would be -1, so absolute value of -1 would be 1, and 1 minus 4 would be -3. Okay, now again, -3 is going to be a bit of I think it's going to be trickier, because you are going to have different things. So -3, and this would be -1.5. And then 1, like if you had $1 and you minus the $1.50, if you could, you would be in debt $0.5 or half a dollar or 50 cents. And I still have to make it positive, so this would be positive 0.5 minus 4, so that would be -3.5. Okay, now let's go ahead and get the next one, so that would be -2. And again, these even numbers should be a little bit easier, so to half of -2 would just be -1. And that would be 0, absolute value of 0 would be -4, so that'd be -4. -1, so I'm gonna go ahead and take the same one and plug it into -1. And that would be 0.5. 0.5 plus 1, well, actually that would no longer be a negative number. It would be a positive number in here now, because 1 is bigger than negative, like what would again be 50 cents. 0.5. 0.5 minus 4, which we kind of already knew that, would be -3.5. And if I plug in 0, anything times 0 is going to be 0. 0 plus 1 is 4. I'm sorry, 1. 1 minus 4, and that would be -3. So that one was kind of easy. We didn't even have to do anything. And 1 times anything is going to be that same number. So this is half plus 1, which would be 1.5. 1.5 minus 4 would be negative 2.5, which again is verified because we've already gotten this one. We should also graph this to make sure that we have our number. So make sure it's symmetrical. Let's see, negative 5 minus 2.5. So that'd be right here. So right between those two numbers. Negative 4, negative 3. And then third one here is going to be negative 3, negative 3.5. Middle one is going to be negative 2, negative 4. Oh, and over here we have negative 1, negative 3.5. 1, 2, 3, and then 0.5, okay. 1, and then 0 is negative 3 over 1 down 2.5. So we have this. So we've seen stretches where it kind of makes it like stretched like this, but we've also seen ones that are what this would be. So this would be a compression, and it's if you imagine it, it's like there's this really nice YouTube channel. Well, it kind of gets boring after a while. I've already watched like all the videos, but they have a big crushing machine and it just like crushes everything. And you can see all sorts of things like hammerheads getting crushed and Play-Doh getting crushed and stuffed animals. But anyway, anytime you squish something, it usually kind of, you know, goes a little bit more flat. So now we have this one graphed. And all reals, good enough. And with the range, we just want to know what either the lowest number we can pick or the highest number, which in this case, there is a lowest number. So Y values have to be greater than, and we can look right here, look at the vertex. So we know that our vertex is here at negative 4. So the Y value has to be greater than negative 4, but it can also be equal to, so it's Y is equal to or greater than or equal to negative 4. All right. All right, now on to the last one for this one here. So this is another piecewise function. So remember, whenever we're graphing these piecewise functions, we want to look at the rule first. And I usually do that by marking out the rule change area. The rule change line is, I call it sometimes, you know, I call it different things, but it's where the rule changes. So in this case, it's 4. So I'm gonna go ahead and put 4, mark it out here. And we're gonna erase it later. Or I guess in this case, you can go ahead and leave it on. That's another thing you can do. And it looks like our first line is going to be a basic linear function. And again, if you need to write that down, you can just write it down as y equals negative 2x plus 1, and it's going to be the same way. And then it's going to be down 2, turn it into a fraction, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So it looks like we're going to have a long line. Okay, and then, oops, wrong kind of line. And we're going to need to do our best to write the line all the way through here. And in this case here, we also want to make sure that we cap it off with the right kind of, end, right? Cap. So in this case, we would have an open circle because there is no or equal to. Because if I pick 4, I don't use the top one, I'm going to use the bottom one. That's the rule I would be using here. Now, again, I mark the rule area change first because in this case here, look at this line, we have an absolute value. So we would have absolute value of x minus 3. So we're going to do the same thing. X minus 3. Oh, I don't really need the absolute value things if I'm going to just set it to 0. So in this case here, it'd be x equals -3, which would be over here. And well, we'd have to find some way of doing this. Now, we don't need to pick values that are going down, because actually anything on this side of the line, we don't even need to graph it. So one thing we could do is just skip that and go straight to using these x values. So x value, so what is this? 4, 8. So let's go with 5. So f of 5. So I don't even need to bother with anything on this side. F of 5 equals, so let's see, 5 minus 3. 5 minus 3 would be 2. 5 minus 3 is 2. So, okay, that makes sense. No, wait, 5 minus 3 is 2. Yeah. So that means over 5 up 2. Okay, and then let's do the same thing with 6. F, and I really should have started on the line. I really should have started on the line. 6 minus 3, and that would be, well, it would be positive 3, but it would just be 3. So over 6 up 3. Over 6 up 3. And then this should give us a good idea. And we can keep going with this, because now I can kind of see what's going to happen. We're going to have, it's supposed to look like this. This is what the full graph should look like. Okay, that's what the full graph should look like. But it's not a full graph, because we don't need this line, and we don't need the line all the way. We just need it to stop maybe right here. And then we need to cap this line off. So even though we had to do a little bit of work, it really didn't turn out to be more than just something that just looks like a regular linear function. So now we just have our graph. Okay, hopefully that worked out pretty well. So now we just need to get our domain and range sorted out. So to get the domain and range, well, it shouldn't be that hard. It would be all reals, oops, caps lock. And range. So again, start with the lowest value, or sometimes if you know your line's not going, like if it's going down, you want to get the highest value. But in this case here, range would be, well, we want y values greater than what looks like to be -7. Now, in this case, there is no or equal to. There is no or equal to because there's an open circle here. So if I tried to get 7, I can't get 7. Using either of these rules, I can't get -7. All right, so that's why there's a hole here. And if I pick 7, if I picked, say, 4, I would have to use this line here. I'd have to use that one. Anyway, so let's go ahead and get on to number 8. And I'm trying to think, I'm not sure if I would have enough time. It's been about an hour. I've got about like maybe 10 more minutes. Okay, so let's see. Rule changes at -3 because I have 2 of them at -3. And then I have 1 at 2. I'm going to try to go through this one hopefully a little bit faster. In fact, actually, I don't really need this one either. And I'm going to go ahead and try to pick, let's see. For x values less than -3, so I'm going to just pick a couple of these. So I'm going to pick f of -4. And that's going to be 2 times -4 absolute value minus 4. And then let's see, I'd have to do the same thing with maybe -5. And I really should do one more, like negative, oops, that should be times -6. And I think this is the only one that's kind of tough. The rest of these look like they're going to be basic lines, which lines are going to be a lot easier to work on than, going to be a lot easier to work on. All right, so 2 times -4 would be -8. Take the absolute value of -8, you get +8. 8 minus 4 is going to be 4. So -4 up 4. And I wish I could, well, let's see. Okay, let me just put that right here. So -4, 4. And then the next one here would be -5. So if I input -5, what do I get out? So -5 and 2, multiply them together, you get -10. -10, take the absolute value of that, you get +10. 10 minus 4 would be 6. So back 5 up 6. And we just need to know the pattern of what's going on. All right, let's just get the pattern. So this would be -12, but then take the absolute value to have +12, and that'd be 6. I'm sorry, 12 minus 4, and that would be 8. So -6, you get 8 out of it. Whew. Okay, so back 6 up 8. Or is it 8? No. Wait, it would be 12. 12 minus 4. 12 minus 4 is 8. Or did I graph one of these points in the wrong area because it doesn't line up? -4 up 4, -5 up 6. -5. That'd be 10 minus 4. That would be 6.
You need to go up one more.
Which one? This one?
4, yeah.
Middle one, okay. Oh, 8 is up here. Okay. All right, okay, so yeah, it didn't line up, so I knew something was a bit off. So yeah, 8 is the edge of the graph, and I should have known that. So, all right, that takes care of our first line. Now, we also have to know where to cap it off. So I'm gonna need, so just looking at the pattern, I can already tell it's gotta be a straight line. So if I just connect these dots, no problemo. All right, and that was probably the only tough one. I think the rest of these are gonna be kind of easier. Whew. So it looks like we just have a horizontal line at -5. So that one should actually be a pretty easy one. And it has no or equal to's. So I'm gonna stop a little bit short because I know I'm gonna cap these off with open circles. And then over here, x minus 2. So this is just a line, so it's gonna go start from -2 and then up 1 over 1, up 1 over 1. So it's gonna kind of look, well, it would look like that actually. But I'm gonna make my line a little bit better. And this one looks like it will be capped with a filled circle, the closed circle, because it is has the or equal to. So we get this thing that kind of looks like an angry face. And the domain in this case here would be, now with these ones, you got to be careful because sometimes there will be a hole, but this this opening is covered by that closed circle, and same thing with this one here. So we do have a continuous line that's able to kind of move from one side to the other side without any holes or gaps or jumps in there. So in this case here, this would be all reals again. And then range, okay, so this one's gonna have a disjoint set of range. So the range is gonna be, let's see, starting from the bottom, working our way up. The lowest number we have is -5. So y equals -5. And then we're gonna have that big U that means and, it's the union symbol. It's gonna start again from 0. So at 0, we have this point right here. And we need y values greater than 0. But since there's a dot there, that dot means that we are going to get n or equal to there. Okay, let me see how much further we would have on this one here. So I'm gonna just scout ahead and I'm gonna look at the packet. Which it doesn't look like there's actually that many of them. And actually in this case here, we only did 8 of them. And it took us about an hour to do 8 of them. So I probably will not be able to finish these because it looks like we are gonna have 2 more of them. There's gonna be another lesson, but we might save this one. I don't wanna wait, I don't wanna do it tomorrow, but I mean, I'll probably make it extra credit or something. I mean, because I don't want to have 2 split lessons in 1 week. So that's probably what I'm going to do. I'm probably going to post a video tomorrow. So as always, I still want the tutoring time. I still want there to be tutoring time on Fridays, just as always. So you can come and ask questions at the regular times. But I also do want this to be covered, even if it's just, it's a lot of the same thing. You do the same thing for making the table of values. The only thing is you are going to use dashed lines and solid lines depending on what kind of inequality symbol you have. You're also going to shade above the line for greater thans and below the lines for that. It's largely the same thing. The only thing that's different is this, and you're going to have to shade one side in. And like I said, we'll probably save that for tomorrow, and I'll make it extra credit so that way you can just watch the video. But again, if you go to the regular classes, it's not going to have the lesson. Instead, it's going to have the tutoring. It's going to be the tutoring time. So again, look for the video on this one. Make sure you're subscribed to the channel so you get updates on all the newest videos. And, you know, like, share, and subscribe this video, and make sure you visit my sponsor so that way I can get more money. No, I'm kidding. I don't have a sponsor. Anyway, that'll be all of it for today, and I will see you next time. Bye-bye.
Okay, bye.